Hi there. Let me start with a small riddle. The riddle is set in ancient Greece, where Achilles, the fastest human alive, is dared by a tortoise to hold a running contest. Achilles agrees without hesitation. After all, tortoises are very slow runners. He even gives the tortoise a head start. The question is, who will win the contest? Everyone agrees that Achilles will catch up with the tortoise and win. Everyone except for one stubborn philosopher, Zeno of Elea. He argues as follows. After the start of the race, Achilles will have to cover the head start that he gave to the tortoise before catching up with him. But when Achilles has run that distance, the tortoise will also have moved. So there's still some distance between them. Achilles also has to run this distance, but by the time he has done so, the tortoise has moved too. So again, there is some distance between them. Achilles has to run this distance as well to catch up with the tortoise, but again the tortoise will have moved, and so on. Since this process goes on indefinitely, Zeno argues that Achilles will never catch up with the tortoise. The distance between them will become smaller and smaller, but Achilles will not win the race. The real riddle is, what is wrong with Zeno's argument? Let's look at the contest in a more quantitative way. Suppose Achilles runs at 4 meters per second and the tortoise runs at 1 meter per second. This is extremely fast for a tortoise, but it works nicely in calculations. Suppose the tortoise gets a head start of 1 meter. Let's also keep track of time elapsed after each step. We start at t0 equal to 0. First, Achilles will run 1 meter. This takes a quarter of a second, so t1 is equal to 1 over 4. Then, the tortoise will have moved by a quarter of a meter, so this is the new distance between them. Achilles runs this new distance in 1/16 of a second, so t2 equals 1/4 plus 1/16. The tortoise then has moved by 1/16 of a meter. Achilles runs this distance in 1/64 of a second, and the tortoise will have moved again, etc. In fact, each step in the process lasts 4 times shorter than the previous step. How long does the whole process take? The total time is equal to 1/4 plus 1/16 plus 1/64, etc. An expression with infinitely many terms. Such an expression is called a series. Since each term is 4 times smaller than the previous term, we can conveniently write it using the sigma notation. What is the value of this series? Zeno argues that it is infinite, since we are adding infinitely many numbers. But common sense says that this cannot be right. In fact, the terms should add up to exactly the time at which Achilles catches up with the tortoise, t equal to 1/3 of a second. Who is right here? The way to analyze this is as follows. Consider the time elapsed after n steps. This is a finite sum, and it turns out that it can be compactly written as 1/3 times 1 minus 1 over 4 to the power n. Now we simply take the limit of n to infinity and find that it equals 1/3. So all steps together take 1/3 of a second to pass. Our common sense was right, Zeno was wrong. However, Zeno does have a point. Adding infinitely many numbers may lead to infinity and can be very subtle in general. Think of the sum 1 plus 2 plus 3 plus 4, etc. It keeps growing, and it will become infinitely large in the limit. And what do you think of the following series? The terms get smaller, but it turns out that this too grows infinitely large. And sometimes it is even more subtle. Think of the series with terms alternating between +1 and -1. It is not clear how to associate the value to this. In the lectures to come, we will give a solid mathematical basis to analyze series and to find out how to attach a value to them. Also, as we will see, there are many surprising applications. More about that later.